from Soterix Medical. I'm the product manager. And I'll be talking about non-invasive brain stimulation devices that we provide, since we don't have enough time to talk about the technology itself, how TDCS works, and how it can be used in different environments. I'll focus on the different products that we're offering, and you guys can come back to the table where we can explain how it can be used in different applications. So these are some of the devices that we provide for TDCS. This is one of the technology among non-invasive brain stimulation devices. TDCS stands for transcranial direct current stimulation, and you apply DC stimulation for about 20 to 30 minutes. The device all the way on the other side, the black panel device, allows you to do DC stimulation. The next one is for AC stimulation, random noise, pulses, so you can combine DC, AC, all kind of trials. The third option is when you want to do TDCS, but in susceptible population, let's say stroke patients or children, you can use that. It provides the same amount of current, which is 2 milliamps. That's pretty much the standard for TDCS, but it uses less voltage. This is using our proprietary technology. The next one is the clinical trials device. This is really meant for double-blinded clinical trials. You can program different settings, and depending on your trial, you'll be able to deliver stimulation. And the most recent entry is the handheld device. This allows you to program the device on the fly for different settings, 10 minutes, 20 minutes, whatever stimulation protocol that you want to do, and you can deliver stimulation in a double-blinded fashion. Now, these are all TDCS, which is how basically this field started, transcranial direct current stimulation, where you use one anode, one cathode, and you use the sponge electrode. In 2008, we introduced the high-definition TDCS approach, which instead of using the 2 electrodes, using saline solution, you can use gel and electrodes, and you can use a lot more electrodes to get more focality. It started with a 4x1 stimulation, where it allows you to have one anode and 4 cathodes around it. And then we moved on to MXN9, which allows you to do 9 different channels, and you can play around with different montages using our software. It allows you to select a brain region that you're interested in, and the software will tell you where to position those 9 electrodes and how much current you need to inject from those 9 electrodes to target the brain area. And we have just launched our MXN33 system. This allows you to control the stimulation parameters using software. So this can be used in closed loop fashion. You can use up to 33 channels if interested, but if less channels are needed, those can be used. And this can also be used for multi-site targeting. So if you're using TDCS where you want to target 2 different brain regions at the same time, MXN33 is something that can be used. And now to put it all together, while we are here, how the system can be used with wearable sensing EEG. So with our collaboration, we have a special type of holder that allows you to add this holder right in the EEG set, and you can use that specific location for stimulation. So you will use that spot for stimulation, and the rest of the electrodes will be used for your EEG recording. So yeah, that's how the 2 systems are combined, and they can be used in this fashion. Of course, we have a table back there where we can show you our software and some of these devices.